from the previous waypoint target altitude, known as geo-referenced backward. It is important to note that geo-referenced forward climbs, as used in a departure procedure, require a target altitude for the active waypoint, set either by the pilot or from the database, and not all departure procedures have altitudes coded in the database for the waypoints. The geo-referenced backward method is only used when the current leg is part of a procedure requiring a minimum climb gradient and is intended to inform the pilot if the minimum climb requirement is not being met. When the target altitude is achieved, the boxes level off until another target altitude is established. For example, this departure procedure requires a climb gradient of 420 feet per nautical mile to 13,000 feet. In this case, set the VNAV climb angle by choosing Menu, then push Bugs, then push VNAV CDA. Choose Climb Angle and set the desired angle. Note that it is shown in both degrees and feet per nautical mile. The Skyway boxes will now indicate a climb at that angle from the runway to 14,000 feet and will climb above you if your aircraft is not maintaining the required climb gradient. Also, use the VNAV function to enter the crossing altitudes for the waypoint, since they are not coded into the database by Jeppesen. To set VNAV altitudes, push Active. Then scroll through the departure waypoints with the control knob. Dashed magenta lines indicate that no altitude is coded for the procedure. At the desired waypoint, push VNAV in the upper left corner of the PFD. Then use the control knob to set the assigned altitude. Push Enter. This may be repeated for any subsequent waypoints. Descent planning along the route can be facilitated as well. Simply enter assigned altitudes next to each waypoint by using the Active button and then the VNAV tile in the upper left corner of the PFD. A target altitude bug may be set, which is similar to an altitude preselector. It creates an immediate climb or descent based on VNAV angles chosen by the pilot and overrides VNAV altitudes. Skyway descent angles are based on the VNAV descent angle set using the Bugs function, except inside the final approach fix, where the HITS descent angle is computed from the Jeppesen nav data. To override all VNAV functions and go up or down immediately, set a target altitude bug from the Bugs menu. Note that the target altitude bug must be turned off during published procedures to enable the VNAV altitudes for the procedure to sequence correctly. Be advised that the highway in the sky does not guarantee terrain separation unless you have selected a published instrument procedure or you're on the final approach segment of a vectors to final approach. As with any navigation device, it is possible to generate HITS guidance that will impact terrain. However, the synthetic vision and TAWS functions are designed to alert the pilot to potentially hazardous conditions. Also, it is important to know that the HITS is always based solely on GPS. Radio navigation and autopilot flight director elements are displayed using conventional symbology. Even though the HITS traces the route that the pilot has chosen in 3D, a GPS WAS CDI is provided at the bottom of the PFD as a primary reference for lateral guidance. The course is indicated by the magenta triangle. The triangle points up for a to indication and down for a from indication. The triangle turns yellow at full scale deflection. To the left of the CDI is the scale, which is automatically set to 2 miles en route and 1 mile in terminal mode. It is also an indication of RNP value. During an approach, the scale gradually decreases to 0.3 miles at the final approach fix and becomes angular like a localizer when inside the final approach fix, indicated by ANG, which also implies RNP 0.3. To the right of the CDI is the OBS course, followed by an A for automatic or an M for manual. Remember, this CDI is always based on GPS. Active waypoint information, including identifier, type, bearing, and distance, is always shown in the lower right corner of the PFD. By pushing the Active button, all VNAV altitudes associated with flight plan waypoints can be reviewed. Above the waypoint information is an optional mini-map that shows the aircraft's position relative to the active waypoint, along with the current segment of the route or procedure. The mini-map scale is set automatically to show only the active waypoint. A traffic thumbnail view can be selected instead of the mini-map. The traffic thumbnail view will also scale automatically as a target approaches. If not selected by the pilot, an alert will cause the traffic thumbnail to appear on the PFD. The PFD can display a conventional HSI centered on the flight path marker. Like a mechanical HSI, it can be slaved to the GPS or either of two VHF nav sources. This HSI is conventional in behavior. The course needle turns yellow at full-scale deflection, and the deviation dots are automatically decluttered when not needed. The selected course is displayed in magenta above and to the right of the HSI. A white dot on the course needle provides the to from indication. The HSI is shown automatically upon selecting a VHF nav as the HSI source. It must be shown manually by the pilot when GPS is selected as the HSI source by using the declutter menu on the PFD. HSI and conventional flight director symbology are mutually exclusive on the PFD. When the HSI source is set to a nav radio that is receiving a valid ILS signal, the HSI is replaced with a localizer needle and glide slope scale that function conventionally, except that the needles turn yellow at full-scale deflection. Only the localizer needle is shown for localizer-only approaches. The localizer needle may be automatically synced to the final approach course by using the ILS course sync option under the Nearest ILS menu. If the HSI or localizer needle is within 1/2 dot, the dots are automatically decluttered. When the Efis is interfaced to a marker beacon receiver through the analog interface unit, conventional marker beacon indications are provided just above the CDI. The Flight Logic Efis features the world's first synthetic vision primary flight instrument, meaning that terrain, obstructions, traffic, navigation symbology, and even runways all appear in the correct scale and perspective right on the PFD. This breakthrough technology allows pilots to see what's out there, even in zero visibility conditions. The display is conformal, meaning that the background image is correctly aligned with pitch and directional scales. So, an object's position outside can be determined by comparing its location on the display with these scales. For example, an object that appears 5 degrees above the artificial horizon line and 10 degrees left of the nose will be at the same coordinates outside. This is extremely useful for locating traffic, avoiding terrain, and locating the runway on a non-precision approach that is not aligned. The TAS terrain database is used to generate a grid representing terrain that extends up to 15 miles ahead of the aircraft. An actual horizon line, where ground meets sky, is drawn at a variable distance determined by aircraft altitude. The terrain grid squares on the PFD measure approximately 2,400 feet square at the equator and become narrower toward the poles like the grid lines on a globe. The terrain display uses an atmospheric perspective technique in which the terrain grid lines fade into the background color to enhance the 3D effect and prevent foreground occlusion, a condition in which objects in the foreground are camouflaged against a similar background. It also reduces eye fatigue during long IFR flights. Towers, antennas, and other obstructions in the FAA's database are shown conformally in conjunction with terrain. If the top of an antenna is above the artificial horizon, it is above the aircraft's altitude. Runways and traffic are displayed independently of terrain. Runways are shown at the correct length and width. The usable portion of the selected active runway is highlighted in light gray. All other runway surfaces are shown in dark gray. Traffic is shown using standard TCAS-1 symbols. The number to the left indicates the horizontal distance in miles. The number above or below indicates the relative altitude in hundreds of feet. A climb or descent arrow indicates a vertical speed greater than 500 feet per minute. Hollow blue symbols are distant targets, while solid blue symbols are nearer. Threatening traffic is displayed as a yellow circle and is accompanied by a voice caution.
Traffic. Traffic.
Flight Logic Efis installed in helicopters features Chelton's unique hover vector technology. The hover vector appears below 30 knots and consists of a gray dot moving around inside two concentric rings centered on an expanded waterline. Representing a view from above, the gray dot moves relative to the center white dot to indicate the direction and velocity of drift over the ground. The inner ring is 15 knots, and the outer ring is 30 knots. Superimposing the two dots will result in a still hover. Above 30 knots, the airspeed indicator comes alive, and the hover vector is replaced with the flight path marker. The Flight Logic PFD will automatically enter an unusual attitude recovery mode anytime the pitch exceeds 25 degrees from level. All synthetic vision elements are removed for clarity. Red chevrons point toward the horizon, and a sliver of the artificial horizon remains, regardless of attitude, to indicate the closest direction to regain straight and level flight. The CDI and directional scale elements are retained to allow continued navigation for aircraft that can sustain extreme pitch angles in a climb or descent. The normal symbology returns when the aircraft is within 5 degrees of level. Okay, time for a quick review. The PFD shows all primary flight instruments over a forward-looking view of the outside world, including terrain, obstructions, traffic, waypoints, and runways. What you see on the screen is what is outside in the same relative position. The Skyway is a predictive flight director that gives you lateral and vertical guidance along your route from takeoff to touchdown, and the flight path marker is where your aircraft is going. Fly the flight path marker through the boxes and use it to navigate precisely to an object on the screen or to avoid colliding with it. The Flight Logic Mfd is the same actual device as the PFD, but it is configured to show a moving map, a reversionary or backup PFD, an HSI, a dedicated traffic display, or a dedicated weather display. In some installations, it may show an engine and systems display as well. The MFD shows air data in the upper left corner, including winds aloft, crosswind component, wind direction indicator, density altitude, outside air temperature, isotemperature, true airspeed, and ground speed. The wind direction arrow is relative to the aircraft symbol in the center of the screen. Density altitude is shown in yellow when the temperature is above standard day conditions. Outside air temperature may be configured for Fahrenheit or Celsius during installation. Like the PFD, the lower left corner is reserved for caution, warning, and advisory flags. A Zulu time clock, timer, and various mode enunciations are located in the upper right corner. Navigation info is shown in the lower right corner, with waypoint identifier and type, bearing, distance, and estimated time en route to the active and destination waypoints. Estimated time of arrival may be chosen if desired. Fuel range and endurance is shown below the navigation information for easy comparison. Voice warnings are provided for minimum fuel quantity. A caution is also provided if the aircraft cannot fly at least 100 miles beyond the destination. To prevent nuisance alerts, this function is disabled in climbs. A directional scale encircles the aircraft symbol and may be shown in an arc format or as a full compass rose. The directional scale elements are the same as on the PFD. The white triangle is heading, the green diamond is ground track, and the magenta star is the bearing to the active waypoint. A heading bug set on the PFD will show simultaneously on the MFD and vice versa. A dashed green lubber line connects the aircraft symbol to the ground track symbol to indicate the aircraft's straight and level track over the ground. The flight plan is shown as a solid white line connecting the waypoints along the route. Missed approaches are shown with a dashed line. The active leg is shown in magenta. The magenta leg on the map is the line along which the Skyway boxes on the PFD are aligned. A dual RMI, or radio magnetic indicator, and ADF can be superimposed over the moving map. The needle with one line represents NAV1. The needle with two lines is NAV2. And the ADF is a line with a circle on the to end. When banking, a thin white line, called the projected path, extends from the nose of the aircraft to indicate the wind-corrected track over the ground for the next 1 minute up to 180 degrees. The projected path is used to intercept courses, fly procedures with precision, and avoid hazards. Terrain is displayed in real time on the moving map and is differentiated as non-threatening and threatening terrain. Terrain blocks on the moving map measure approximately 600 feet square at the equator and are displayed around the aircraft in a grid approximately 100 miles square. Non-threatening terrain is shown in dark olive and dark brown. Green represents terrain that is within 2,000 feet of the aircraft's altitude. Dark brown is within 500 feet of the aircraft's altitude, and light brown is at or above the aircraft's altitude. Black on the map is terrain more than 2,000 feet below the aircraft's altitude. Water is shown in deep blue and takes precedence over other colors. Non-threatening terrain is shown to enhance situational awareness and assist in decision-making. Terrain that generates a TAWS alert is considered threatening and is displayed in red or yellow based on level of threat. Because many published procedures are flown below the tops of surrounding terrain, yellow and red are not used for non-threatening terrain, regardless of relative altitude, in order to prevent the pilot from becoming desensitized to caution and warning colors. Yellow on the moving map requires pilot attention, while red demands pilot action. The terrain may be manually decluttered by the pilot, but threatening terrain will still be automatically shown on both the PFD and moving map in conjunction with a TAWS alert. Since terrain elevations are calculated every 600 feet, some terrain detail is lost. Chelton has developed a proprietary process to ensure that only the lowest terrain detail is lost and to verify the accuracy of the terrain elevations displayed on the moving map. This process indicates that the average error for the terrain display in the United States is about 12 feet. Outside the United States, where the source data is lower resolution, the average error is about 150 feet. These errors will only be noticeable when flying very near the ground in mountainous areas. A terrain NOTAM identifying airports in areas having terrain errors greater than 100 feet is available at cheltonflightsystems.com. These are primarily low-use backcountry airstrips, but pilots operating in mountainous regions should be familiar with this information. All owners will be notified when this NOTAM is updated. Towers, antennas, and other obstructions within 12 miles are displayed as an inverted V shape on the moving map in conjunction with terrain. If the top of an obstruction is within 2,000 feet of the aircraft's altitude, it is shown in yellow. If the top is within 500 feet of the aircraft's altitude, it is shown in light red. If it is at or above the aircraft's altitude, it is shown in dark red. Obstructions generating a caution are surrounded by a yellow circle and are accompanied by a caution flag and an annunciation. Obstructions generating a warning are shown in a flashing yellow circle and are accompanied by a warning flag and annunciation.
Obstruction. Obstruction.
Turn away from any obstruction generating an obstruction alert. When a target altitude is set on the PFD, or VNAV altitudes are selected in the active waypoint list of a flight plan or procedure, a green arc, called the Altitude Capture Predictor, will be displayed ahead of the aircraft symbol on the moving map to indicate the point at which the target altitude will be reached. Use this to comply with clearances like
Cross 10 north of Drake at 14,000.
It is also handy for clearing airspace and terrain in climbs. A light blue line surrounding the aircraft symbol defines the dead stick glide area or the area into which a power-off landing can be made. A variety of factors are used to compute this, including altitude, wind, and terrain. The line indicates the point at which the aircraft will be at 200 feet AGL and is continuously updated during the descent. At high altitudes, where the dead stick glide area extends beyond the terrain grid, it is not shown. It is updated continuously in a descent, but has no way to account for changing winds beneath the aircraft. This function may be decluttered, if desired, by using the Format menu and then Function Declutter on the MFD. Airports, navigation aids, and fixes are displayed on the moving map and can be used as waypoints. Light blue airport symbols have IFR procedures associated with them, while magenta airports are VFR only. The back cover of the pilot's guide has a quick reference for map symbols. Lightning is shown on the moving map when connected to a WX500 storm scope. New strikes show up as yellow strike symbols. The strike symbols turn into crosses that gradually shrink and disappear as they age. All strike activity can be cleared from the map by choosing Menu, then clear strikes. Traffic is shown on the moving map as well, using standard TCAS symbols. Relative altitude is shown above or below the symbol in hundreds of feet. As on the PFD, an arrow indicates a climb or descent if the VSI exceeds 500 feet per minute. Range can be determined using the moving map's range ring. Hollow blue symbols are distant targets, while solid blue symbols are closer. Threatening traffic is displayed as a yellow circle and is accompanied by a voice caution.
Traffic. Traffic.
Threatening traffic causes a pop-up condition on the moving map, which scales the map to highlight the traffic, even if the traffic function has been decluttered from the display. The traffic thumbnail view on the PFD will also appear when an alert occurs. If the HSI function has been chosen on the MFD, traffic will only appear on the thumbnail view on the PFD. Runways are shown on the moving map in the correct scale for length and width. All runways at the departure and destination airport are shown. The usable portion of the selected active runway is light gray. All other runway surfaces are dark gray. When set to north up at the lowest map scale setting, this is a very useful presentation for avoiding runway incursion, and when used with an airport diagram, taxiing at unfamiliar airports is easy. Special use airspace is shown using colored lines. Red is for restricted and prohibited areas. Yellow is for MOA and warning areas. Blue is for Class B airspace, and green is for Class C and some other controlled airspace. Heavy airspace lines indicate the aircraft will enter the airspace at the current altitude. Thin lines means the aircraft will remain clear of the airspace at the current altitude, but you are within 500 vertical feet. A dashed thin line means the aircraft will clear the airspace by more than 500 vertical feet. The moving map can be formatted as a centered compass rose by choosing Menu and then Format, or as an arc. Scale, representing the distance from the aircraft symbol to the compass rose, can be set from 1 nautical mile to 400 nautical miles. Distance to the range ring, halfway to the compass rose, is indicated in the lower center of the display. The moving map may be replaced with a traditional HSI display, a dedicated lightning page, or a dedicated traffic page by choosing Menu and then Display. The MFD can also display a reversionary primary flight display with a single button push. Okay, time for a quick review. The MFD can be viewed as a moving map, backup or reversionary PFD, electronic HSI and RMI, dedicated lightning display, or dedicated traffic display. It can be configured heading or north in the up position. Traffic and lightning displays can be shown with or without the route overlaid. The magenta waypoint and course leg are active, and missed approaches are shown as a dotted line. Airspace classes are identified by color, and incursion clearance is identified by line type. Threatening terrain and non-threatening terrain is differentiated by color, and red or yellow on the display demands action or attention. This section will cover the most common procedures performed with the Efis. There are many functions that are used less often that are not covered here. Please refer to the Pilot's Guide to become familiar with additional functions that you wish to use. The Flight Logic Efis has a built-in ground training application. Access this feature by placing a card in the data card slot and applying power to the screen. Use the control knob to scroll to Run Demonstrator Training Program and push to enter. An adapter plug that allows the unit to be run at home is available from your dealer. You can remove a screen and take it home for practice, but a licensed mechanic or avionics repairman must sign a logbook entry when it is reinstalled in the aircraft. When first powered up, the demo will begin near Reno, Nevada. When you select a flight plan, the Efis will take several seconds to jump to a point near the first waypoint of the route. So if you want to practice an approach at Jacksonville, just create a flight plan from Jacksonville to anywhere and activate it. After the demo jumps to Jacksonville, push Nearest, then choose Airport, then choose Jacksonville or another nearby airport, and practice your procedures. This ground training application allows you to perform any Efis procedure you would use in flight except takeoff and landing. When you're finished, power off the display and remove the card. The displays are controlled with 8 buttons, 4 on each side and 2 knobs. When no menus are displayed, each button has a specific function indicated by its label. These are the same for the PFD and MFD. Pushing FPL enters the flight plan function. ACTV stands for Active and is for working with waypoints in your active flight plan. Info is for accessing waypoint information. OBS is used to set a manual GPS or OBS course and to select the HSI source. Choosing menu shows the main menu. HDG is for setting a heading bug. NRST stands for Nearest and is for choosing the nearest airport, NavAid, User Waypoint, ILS, Flight Service Station, or Air Traffic Control Center. The D with an arrow through it activates the Direct To function. The buttons do the same thing on both the PFD and MFD. When the menu button is pushed, the main menu presents a variety of options on the screen adjacent to the buttons. Pushing the button associated with a menu item will activate that menu function, just like using an ATM to get cash. The back menu is always shown in the upper left corner and takes you back one step when pushed. Use this when you make a mistake. The exit menu is always shown in the upper right corner. Use this to immediately clear all menus from the screen, preserving the original values. Note that the menus do not cover up any critical flight information. Turning the left knob sets the screen brightness. Pushing and turning sets the control backlight brightness. With no menus shown on the PFD, the right knob sets the altimeter. With no menus shown on the MFD, it sets the display scale. If scrolling menu or alphanumeric entry boxes are shown in the lower right corner, the right control knob is used to make selections or enter letters and numbers. Turn the knob to choose an option, then push to enter. Always remember to push to enter. Pushing the control knob on the MFD instantly switches it from the map to the backup or reversionary PFD, to the engine display if equipped, and back to the map again. The local altimeter setting is entered automatically on startup based on the nearest IFR runway end elevation. To set the altimeter manually, just turn the right knob on the PFD and push to enter. At the beginning of each flight, the MFD will display a prompt to set the fuel totalizer and will show the amount of fuel currently on board. Turn the knob to set the amount on board if you added fuel. Press the Mains menu to quickly set to the amount held in the main tanks or at the tabs. Press Full to set to maximum quantity with all tanks full. Push the knob to enter. Some installations may not include the fuel totalizer function. By now, you should be seeing a pattern. Virtually all control of the system is done by pressing a button, then turning and pressing the control knob. This is easy to do in turbulence, and since the menus don't cover up any critical information, any task can be postponed in the middle in order to fly the airplane or communicate. If you pause for a while during a menu operation, it will wait patiently for you to resume. Use Exit if you want to abandon an operation partway through. Remember, turn and push the control knob. Navigation using the Flight Logic Efis is extremely simple, but it does rely on a fundamental concept. All navigation procedures require an active waypoint. A waypoint may be a single point, like an airport or intersection selected using Nearest or Direct To, or it may be part of a flight plan that has been loaded from a collection stored on the system. To go to a nearby airport, VOR, NDB, Fix, or User Waypoint, push the Nearest button and use the knob to select the type of waypoint. The 20 nearest waypoints will be shown along with bearing and distance. If you want to get nav data information about the waypoint before you make it active, push Info. Push Back to return to the waypoint list. Then, use the knob to activate the desired waypoint from the list. To navigate directly to a waypoint that is not nearby, push the Direct To button. Then use the control knob to enter the identifier. If there is no active waypoint, the default entry is the nearest airport. If there is an active waypoint, it will be the default. Numbers follow letters. For quickest entry, turn the knob clockwise for letters up to R and counterclockwise for letters after R or numbers. Using a K for airports is optional. Enter at least 2 characters. Push the control knob to advance through empty spaces. If an exact match is not found in the database, a list of options will be presented with symbols identifying the waypoint type. Scroll to the desired waypoint and push to enter. You may create user waypoints 3 ways: by designating present position, using latitude and longitude, or specifying radial and distance from a waypoint. To designate your present position as a user waypoint, choose Menu and then push the soft key labeled DESIG. The waypoint will be automatically named by the system sequentially as OF001, OF002, and so forth. OF stands for Overfly. Once created, these waypoints can be renamed or edited anytime by pushing Flight Plan on the MFD, choosing Create Edit, then choosing Edit User Waypoint. To create user waypoints using lat/lon or radial distance methods, push Flight Plan on the MFD, then choose Create Edit. Choose Create User Waypoint, choose the desired method, and follow the prompts to name and define the waypoint. When editing a user waypoint, you may specify an approach bearing. If an approach bearing is specified, you will be able to activate a VFR approach to that waypoint using the Active menu. This allows the pilot to set up an LNAV, Baro VNAV approach to any point anywhere. This is particularly useful in helicopters for noise abatement procedures or for precise guidance to specific landing sites and for aircraft operating in remote regions or in marginal VFR conditions. Although extremely precise, this approach guidance is for VFR only and does not provide terrain separation. Flight plans may be created and stored for repeated use, or they may be created on the fly by simply setting an active waypoint, then adding or inserting waypoints using the Active menu. To create and store a new flight plan, push the Flight Plan button on the MFD and choose Create Edit. Choose Create New Flight Plan. Using the Add button and control knob, enter the waypoints beginning with the departure point and ending at the destination. Bearing and distance to each waypoint is shown on the left. A graphical depiction of the route will alert you to a misentered waypoint, and a total distance is shown at the bottom. Turn the knob to step forward and backward through the flight plan to edit. Push the Info button to get waypoint information. Push Save, Exit when you are finished. Now you may activate the new flight plan from here by choosing Activate Flight Plan, or exit the flight planner and activate it using the Flight Plan button on either the PFD or MFD. Note that you cannot enter the flight planner on the dedicated PFD, but you can on the reversionary or backup PFD. To activate a flight plan, push Flight Plan, then choose Select. Scroll to the desired flight plan and push to enter. The Efis will load the flight plan and activate the second waypoint. Regardless of whether you chose a stored flight plan, used Nearest, or entered Direct to a distant airport, you can add and delete waypoints easily en route using the Active menu. Push the Active button and turn the knob to review your active flight plan. An asterisk indicates the active waypoint. Insert puts a new waypoint before the waypoint you highlight in your flight plan. Add appends a waypoint to the end of your active flight plan. Select Add or Insert and then use the control knob to specify the new waypoint. Waypoints may be deleted by scrolling to the desired waypoint and pushing Delete. Push the knob to confirm deleting the waypoint. Any waypoint in an active flight plan can be made the active waypoint. Push the Active button, scroll to the desired waypoint, and push to enter. Please note that this will not take you directly to that waypoint. It just makes it the active one in the flight plan. If you want to set a new active waypoint and go directly to it, push the Active button, scroll to the desired waypoint, and push Direct. A phantom waypoint will be created at your current location, and a new route will be drawn to the selected waypoint. It is important to realize that going direct to an intermediate waypoint in a procedure will no longer provide you with guaranteed terrain separation. To allow easy course recentering, the active waypoint will be the default entry when you push Direct To. If there is no active waypoint, the nearest airport will be the default for instant access in an emergency. To get information about a waypoint, like communication frequencies or a crossing altitude, push the Active button, scroll to the desired waypoint, and push Info. Push Back to get info on another waypoint, or Exit when you are done. This is handy for previewing altitudes before starting an approach. Clearing the active route and removing the navigation symbology can be done by pushing Active, then Active Off. Confirm by pushing the control knob. Remember, a menu item in the lower right corner requires use of the control knob. Note that changes made to an active flight plan do not affect the original flight plan stored on the system. If a user waypoint has been edited, it must be deleted from stored flight plans and re-entered. The Flight Logic Efis provides lateral and vertical guidance for all